welcome back. Okay, so our previous lesson, we already talked about the three gases law, which is your Boyle's law, Charles' law, and Avogadro's law. Okay, as you can see in my screen, I already showed to you the relationship between the Boyle's law, which is the volume is inversely proportional to pressure, whereas for Charles' law, volume is directly proportional with the temperature, and for Avogadro's law, the volume is directly proportional to the amount of gas, or we can say that is number of mole. Okay, so from these three gases law, I can derive ideal gas equation. Okay, so let's write down volume is actually directly proportional to number of mole, temperature, as well as 1 over pressure. So how do I get 1 over pressure? This inversely proportional or volume with pressure in the Boyle's law can be translated as well into volume is actually directly proportional to 1 over pressure. Okay, so that's why you get this new relationship. Alright, so if I want to convert this relationship into an ideal gas equation ataupun to change into an equation, alright, so V equals to constant time and temperature over pressure. Okay, so if I rearrange, I will get pressure times with volume equals to a constant time with number of mole and temperature. Okay, if we compare with PV equals to nRT, so our constant is actually your gas constant. Okay, gas constant R. So what is the value of R? You can check on the list of constant that I already shared to you earlier in this semester. Alright, so we're going to use this equation for most of the ideal gas equation exercises. Okay, from this ideal gas equation, ideal gas equation, we can derive another two equation, which is to relate between ideal gas equation with molar mass as well as with the density. So how are we going to determine the new formula? Okay, so I rewrite my ideal gas equation, which is PV equals to nRT. Okay, as we know, okay, N number of mole can be get from mass over molar mass. Alright. Okay. So, I substitute this equation of number of mole into my ideal gas equation. Okay. So, I replace the number of mole with mass over molar mass. Or molar mass also can be represented as molecular mass. Okay, where the symbol for molar mass is Mr. Alright, nRT. Okay, since I want to get a new formula for my molar mass or molecular mass from ideal gas equation, that means I'm going to rearrange my molar mass to be on the left side, and my pressure and volume I will rearrange to be for it to be on the right hand side. Alright, so molar mass equals to mass time with R time with T over PV. Okay, if we can change the molar mass into the symbol, Mr equals to mRT over PV. So this is a new formula that we write from ideal gas equation to determine the molar or molecular mass of a compound. Okay, so you don't have to memorize this formula. You just need to know how can you derive this molecular mass or molar mass formula from ideal gas equation by simply substituting the formula for number of mole which relate mass and molar mass. Okay, the second derivation is from the ideal gas equation. We're going to derive the formula for density. So density is mass over volume. Okay, so that means we need to make sure on our left side we have mass over volume. So rewrite again our ideal gas equation, PV equals to nRT. And from the previous formula, we know that number of mole is mass over molar mass. Okay, so I've substitute this N with the mass over molar mass. So PV equals to mass over MR RT. Alright, so I want density to be on my left side, which is mass over volume. Okay, or we can keep it on the right side. So MR going to be shift to the left side, PV going to shift to the right side, and RT to the left side as well. So pressure time with molecular mass or molar mass over RT equals to mass over volume. Okay, and then this mass over volume is equivalent to density. Alright, so if I rewrite the formula, P mR or T equals to density, which is represented in the symbol of rho, density. Okay, in other words, density. Okay, so every time you want to use your ideal gas equation formula, alright, you need to make sure, okay, every variables you use the right unit. Okay, PV equals to nRT. So your pressure should be in ATM. Your volume should be in liter. R is a constant. Please refer to the list of constant. And temperature should be in Kelvin. And N is in mole. Okay, so if you want to calculate density, okay, density equals to P mR over RT. So pressure again in ATM, mR in gram per mole. Okay, RT is your gas constant. Okay, and temperature is in Kelvin. Okay, if we refresh back, okay, our formula for molecular mass mRT over PV. So this mass is in gram, pressure is in ATM, volume is in liter. So R again is your gas constant. Okay, T is in Kelvin. Alright, so gas constant, there are two different value of your gas constant. So you need to check on, for ideal gas equation, you need to check on the right unit. Okay, for this gas constant, it should be in the unit of per mole per Kelvin and ATM the liter. Okay, so the unit for this gas constant should be mole per Kelvin, ATM and liter. Alright, so check on the right value of your gas constant. Okay, enough for today.